Alright, continuing on with our enthalpy. Now we're going to cover some energy diagrams and some more things about it. If you look on the top right, you have the endothermic and exothermic energy diagrams. Those are kind of what they look like. There's actually half of them. You'll see a real one in a bit. But these are all about reactions. So in a reaction, a certain amount of energy is required to get the reaction started. That's called the activation energy. Okay, so I'll show you what that looks like here in just a bit. Then you have the activated complex, which is the very top of the peak. And that's going to be a very, very short-lived structure that only exists while the chemical is actually becoming the new chemical. So bonds are breaking, bonds are forming. Then you have your delta H, which is also your enthalpy, very similar to Q. And that's going to tell you if it's going to be endothermic or exothermic. So this one's very important, determining endo versus exo. And the catalyst, we don't really use a catalyst a whole lot in chemistry. It's more of a biology thing, but they do occur. Sodium iodide is really the only one we use in this class, but those speed up the reactions by decreasing the activation energy. And those can get really complicated how those work, so luckily we won't get into those a whole lot. But here on the right, you have endothermic versus exothermic. You need to be able to identify each of these as endothermic and exothermic. They'll look a little bit better in the next picture. But an endothermic reaction, energy is gained. An exothermic, energy is lost. So when you observe it, temperature of the surroundings decrease, so it becomes colder, and the temperature of the surroundings increase for an exothermic. Now in the symbols, which is a little bit more important, you're going to have a positive energy for endothermic and a negative energy for exothermic. And then when you see it in a reaction, heat will be a reactant, whereas in the exothermic, heat will be a product on the right side of that arrow. And then graphically, an endothermic reaction has a positive H, so it's going to look like that, whereas exothermic will dip lower on the right than on the left. So moving on, let's label this. This is more like what you'll see. You'll see a lot of these in class. So the first thing we've got to do is label it. It's the activated complex. I think this first one is supposed to say activation energy, but we'll start with our reactants, which is over here, where it starts. Those are the reactants. On the right, where it ends, those will be the products. At the very tip top, that's going to be your activated complex. So those are the easy ones. Then you have, from where the reactants start to the very top of the activated complex. That's going to be your EA, or your activation energy. Then one of the more important ones is from your products to your reactants. That's going to be your delta H, or your enthalpy. When you're doing this one, remember it's always products minus reactants, not the other way around. So number 2 is calculate the activation energy. We're going to go from the complex, which is 700, minus the reactants, which is right there at 300. 700 minus 300 will be 400. This is in kilojoules. Kilojoules. Next, calculate the enthalpy. Remember, this is going to be products minus reactants. So our products are right here on the 200 line. Our reactants are right here on the 300 line, which gives us a negative 100 kilojoules. It's a negative sign, not a dot. And because it's a negative sign, that tells us it's exothermic. The next, draw a dashed line to show what would happen if a catalyst reduced the activation energy by 200. We start 700 with the activated complex. So 100 would be 600, and 200 would be 500. So that's going to be where the activated complex is. And you just kind of make it fit in line with the products and the reactants. Still going to start and end at the same. It's just going to hit that activated complex a little bit earlier. There you go. So the next one is your actually endothermic or exothermic. It's exothermic. It's negative, which is what ours was. And then you see down here for the exothermic reactions, heat is a product. This is what we're talking about with that little graph we saw. If it's a product, it's going to be a negative sign. And if it's a reactant, it's going to be positive, which tells you it's endothermic. That's all you really need to know with that. Skip it. So then we get to here. Identify these as exothermic as endothermic. With the H with the correct sign. You have your arrow here. You have your kilojoules here, so it's a product. So this is exothermic. And our delta H going to be negative. Even though it says positive right here, because it's in the products, it's going to be negative. And the next one, our kilojoules are in a reactant. So this is going to be endothermic. And it's going to be written just like it's written. Positive sign with 180.7. It is important to put that positive sign so that I know you know it's positive, not just writing it and forgetting the sign.